All right, so let's look at the revision on organic chemistry. First of all, what is organic chemistry? Organic chemistry is the chemistry of carbon and its compound. So that is organic chemistry. Now, we have that Friedrich Wohler disproved vital vitalism theory in 1828. All right, so for this lesson, we are going to learn organic chemistry, do the revision of organic chemistry, ask question and answer on organic chemistry. So stay tuned until we are to the end of the video. Share the video. Share the video so that others can see it. So what is the functional group present in alkanols? Alkanols, that is alcohol. So the functional group present in alcohol, okay, is OH. The functional group present in alcohol is OH. And take note, classification of alkanols. It can be classified based on number of OH and based on position of OH. So how do we classify alkanol? Based on number of OH, we have C, okay, we have another C, we have OH. This is one OH. Based on number of alcohol, this is one OH present. Okay, so we can now say primary alkanol if it has one OH. If it has one OH. Now, if it has one OH and is placed as, okay, if you are classifying it based on number of alcohol, one OH is, though, is monohydric. Let's start from the monohydric. Yes, for one OH is monohydric alcohol. Then for two OH, where you have OH here, OH here, okay, is dihydric. Dihydric alcohol. This is classification based on number of OH. Here we have only one OH, and here we have two OH. And for one OH, we call it monohydric alcohol. Under monohydric alcohol, we can talk about the position of the OH. So it is the monohydric alcohol that can now give us primary alcohol, secondary alcohol, and tertiary alcohol, as the case may be. But for dihydric alcohol, it has two OH, and the last is trihydric alcohol, the one that has three OH, trihydric alcohol, it has three OH. The monohydric alcohol has only one OH. Then dihydric alcohol has two OH. Then trihydric alcohol has trihydric alcohol has three OH. All right, so let's look at some questions. But talking about this classification based on number of OH, let's give an example. COH. This is called ethanol. Then CCOH also, but this time around, the OH is 2. OH here, OH here. So this is called 1, 2, 1, 2. So ethan 1, 2 diol. So it's called ethan 1, 2 diol because we have 2 OH. And this one is monohydric. This one is dihydric. Okay, so then 1, 2, 3, where we have 1, 2, 3 OH. We have 1, 2, 3 OH. We call it 1, 2, 3 propan. 1, 2, 3 triol. And this is called glycerol. This is glycerol. Glycerol is having 3 OH. Now, you could be asked a question, but before then, monohydric, based on the position of OH, we have primary alcohol, alkanol, which can show you that here we have OH, okay, and we have only one OH here. At this point, you have H, H, okay, and this is alkyl group, and we have presence of H, 2 hydrogen. So if we have 2 hydrogen attached to the carbon atom that has OH, we have primary alcohol. Primary alcohol. Okay, primary alcohol. It has 2 hydrogen attached to this. Now, if you have secondary, it means COH, CH3, CH3, 1 OH. So this is secondary alcohol. Secondary alcohol in the sense that it has only 1 hydrogen. It has 1 replaceable hydrogen. Only 1. Okay? The one that has only 2 replaceable hydrogen is called primary alcohol. And the one that has 1 replaceable hydrogen is called secondary alcohol. And secondary alcohol or alkanol. So if you want to name it, you have 1, 2, 3. So this is called propan, because it's 3, propan. Then the OH is at 2, 2, or. Okay. Secondary alcohol is propan 2, or. So that is how we have secondary alcohol. Then the third one is tertiary alcohol. Tertiary alcohol, which does not have any replaceable hydrogen atom. Tertiary alkanol does not have any replaceable hydrogen atom. Okay? Does not have any replaceable hydrogen atom. Okay, so let's see how we can answer some questions. But before then, still on alcohol, CnH 2n plus 1 OH is the general formula for alcohol. General formula for alcohol. All right, classify this into primary. Classify this into primary and secondary alcohol. So which one is primary alcohol? Which one is secondary alcohol? Let me see your answer in the comment section. Which one is primary alcohol? Which one is secondary alcohol? Let me see your primary alcohol, secondary alcohol. Classify these into primary alcohol and secondary alcohol. One is calling you. One is calling you. One is calling you. Oh, oh, oh. So now, which one is primary alcohol? Which one is primary alcohol? Classify methanol, ethanol, propan 2 or butan 2 or. Which one is primary alcohol or alcohol? All right. Methanol and ethanol are primary alcohol. Propantu or butantu or are secondary alcohol. Alkanols are polar molecules due to the presence of what? The answer is hydrogen bonding. Check if you got it. If you got it, congratulations. You can tell me in your comment section that you got it. The answer is hydrogen bonding. Next question. Alkanols can be prepared by dehydration of starch. How do we prepare alkanols? It can be prepared by dehydration of starch. So what's the answer? Hydration of what? Let me see your answer in the comment section. Chinyere, you are welcome. Rita Wanfo, you are welcome. Promise Kalechi, you are welcome. Desire, you are welcome. Oluebube, you are all welcome. All right, the answer is Akin. The answer is Akins. So if you got it, congratulations. Next question. What is the product of the oxidation of a primary alcohol? All right. What is the product of the oxidation of a primary alcohol? So a primary alcohol, let's see, oxidation actually, a primary alcohol has only one OH, only one OH. So when it is oxidized, what will it form? When it is oxidized, what will it form? This is just OH. What is oxidation? So what is the answer? So when it is oxidized, what will it form? Good then, precious Mary, you are welcome. So this is what happened. Here is hydrogen, 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 hydrogen. So when you oxidize it, you find out that oxidation actually is either the addition of oxygen or the removal of hydrogen. This oxygen that will be added here will cause two hydrogen to leave so that water can be removed. So you remove water, H2O. So removal of water, H1, 2, H, or this 2H will go. And when the 2H leaves, it will join to this O. So we'll now have CH3, CHO. So we'll be having CHO. How? This hydrogen, one hydrogen will go, then this hydrogen goes also. We'll be left with this hydrogen and see what happens. As this hydrogen is leaving, this one is leaving. Remember, let's pick this alone. Okay? You have that this is already aldehyde. 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 But that is not all. As long as we are talking about oxidation, no, it will not form alkane. So this is aldehyde. Oxidation is removal of hydrogen or addition of oxygen. In this case, we are removing hydrogen. And then let's take this. Hydrogen is removed. This is a bond that will be freed. Then this is also a free bond. Then this hydrogen is there. So this bond will now merge with this bond, okay, to have what we call double bond. Then hydrogen remains here, and we also have this. So this double bond is what we form as CHO, which is called what? Alkana. Alkana. Okay? You see how the thing was formed? Hydrogen is left here. One hydrogen is left here. So this lone bond, lonely bond, or unhybridized bond, we now join this bond here to become double bond. And this double bond is formed with oxygen here. So from here, you have hydrogen O, CHO. Okay, this is how it is formed. That is the only possibility that will be happening here. And now, this also will further be oxidized. It doesn't end here on aldehyde. It will further oxidize to give us what? This time around, you add O to it. So you have CH3, COOH. All right, CH3, COOH. This becomes alkanoic. Okay, alkanoic acid becomes alkanoic acid. Have you seen it? Aldehyde was formed by the removal of two hydrogens. Okay, but here, alkanoic acid was formed by addition of oxygen only. You add oxygen, boom, it will form COOH. And the oxygen will be attached to the hydrogen that is alone. All right? So that is how we form the products. So the products are aldehydes and alkanoic acid. So answer is, what is the product of the oxidation of a primary alcohol? aldehyde, which is alkana. That is the first product. Second product is what? Alkanoic acid. So the first product is alkana. So if they ask you, the immediate first product is alkana. Then second product is alkanoic acid. Like when it further oxidizes, it gives us alkanoic acid. All right. Next question. Um, what are the uses of ethanol? We can use ethanol as antiseptic. Can use ethanol as solvent. Can use ethanol as fuel, as the case may be, because the polarity of ethanol is due to the presence of hydrogen bonding. Okay? Antiseptic, solvent, fuel, and so on and so forth. Now, I'd like you to drop your answer in the comment section. Tertiary alkanols are resistant to oxidation. Tertiary alkanols are resistant to oxidation. Why? Let me see your reason in the comment section. Why? Why? Let me see your reason in the comment section. All right. Tertiary alkanols are resistant to oxidation because they have no hydrogen. Look at it here. They lack hydrogen atom on the carbon with the OH group. They don't have any hydrogen atom on the carbon with the OH group. So there is no way any reaction can take place. No oxidation can take place here. Removal of hydrogen will not be possible here. Okay? All right, so that is the answer. The answer is because there is no hydrogen atom attached to the carbon atom containing OH. The boiling point of Akano is higher than that of alkanes. So the answer, therefore, this question and answer. So what's the answer? What's the answer? Your answer is what? Yes, this is because I cannot have a hydroxy group from all over the pressure. This is because alkanol molecules forms the hydrogen bond. This is because of formation of hydrogen bonds. Let's see who got it. Let's see who got it. Now, the answer to the question is presence of hydrogen bond. Presence of hydrogen bond. That is the correct answer.
Often.
So, what is the process of converting alkanes to alkenes called? The process of converting alkanes to alkenes, what is it called? What is it called? The process of converting alkanes to alkenes, what is it called? The answer is, what is it called? Nelson, you are correct. Dehydrogenation is correct. Dehydrogenation. Dehydrogenation is correct, not cracking. Cracking will give you alkenes, but dehydrogenation will remove hydrogen from alkanes to form alkenes. This is it, yeah. The correct answer is dehydrogenation, not cracking. Dehydrogenation, not cracking. Okay? Dehydrogenation is correct. When you say cracking is wrong, though cracking will give us alkene, but in the presence of something. Okay? So cracking is wrong. The answer is dehydrogenation. Okay, now watch and see how dehydrogen, we talk about what is dehydrogenation, the process of removing hydrogen. So this is hydrogen, 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 hydrogen. So we take away two hydrogens. When we remove this hydrogen, let's remove this hydrogen. So what is left? Okay, you have removed two hydrogen. So you will be left with C, H, H, C, H, H. Then the hydrogen will now bond to be able to carbon and become double bond. So this is why they have double bond in alkene. This is alkene. Why this is alkane? Alkanes. Okay? So the answer is dehydrogenation.
Mommy, I want to drink water. I want to drink water. Daddy, is it red? Daddy, is it red?
No,
It's my book.
it's not apple.
It's my book.
afford them. It's not a book. I'll call on you. Let's make off. Yeah, it's the beginning, man. Let's see how it's the beginning. So what's the answer to this question? What is combustion? What is the process of breaking down large hydrocarbon molecules into smaller ones called? So this is the one that you say is cracking. So this one, cracking, is very, very correct. Cracking is very correct. Which hydrocarbon is used in the production of polyethylene? Polyethylene. Which hydrocarbon is used in the production of polyethylene? The answer is ethane. I hope you got that. The answer is ethane. You should stop that. What is the reaction of alkenes with water in the presence of an acid catalyst called? Reaction of alkenes with water in the presence of an acid catalyst. What is it called? Okay. Answer. Try to know where you got that. What is it called? What is it called? Yeah, John, John So. You are there. You got that correct. John So, you are on point. You got that correctly. Next question. The answer is hydration.
Mama, Daddy, what is
Now, in summary, all right. In summary, hydrocarbons, hydrocarbons are organic compounds that contain only hydrogen and carbon. Example, alkanes, alkenes, and alkynes. So pay attention, let's hit it very hard. So you'll be able to understand the concept. Alkanes, CnH2n plus 2. Alkenes, CnH2n. Alkyne, CnH2n minus 2. Carbon single bond belong to alkane family, and hybridization is sp3. They are called alkanes. That is aliphatic. They are called, aliphatics are alkane alkynes. So aliphatic compounds are alkane alkynes. So that is what they generally call hydrocarbons. Now, for alkanes family, we have XP3, carbon-carbon double bonds. They are double bond, okay? And they undergo substitution reaction. They undergo substitution reaction, okay? These are also called paraffin, okay, paraffin, which is also used for paraffin wax. They are paraffin. Okay, they are paraffin. Then for alkane, bond angle is 109 degree, 109 degree. Okay, tetrahedral structure, tetrahedral structure. Now the first, which is CH4, the first member, methane, is gas. And now methane, ethane, propane, and butane are all gases. So C1 to C4, we have gases. So that you'll be able to get that clearly. Now, we can have a very, very large organic compounds, okay? We can have very large alkanes. These alkanes can be broken down into simpler alkanes. So the process of breaking these large alkanes into smaller alkanes is called cracking. It's called cracking. Also, we can form pure alkanes, or let's say we have what we call petroleum or crude oil. Petroleum is mixture of petrol, diesel, kerosene. It has all other compounds in it. So it needs to be refined. It has impurity. It is crude. So when you refine petroleum, first, you get a gas. You get gas, then you get petrol, then you get kerosene, you will now get diesel using fractional distillation. So petroleum, when refined, will give us petrol. Petrol is used as a normal fuel for automobiles. Then gas for cooking, for heating. Kerosene for heating. Diesel, okay, is also used for fuel too, for mobile. Now, when we talk about petroleum, petroleum is also called crude oil. And when we refine petroleum, we get petrol. This is what we buy as fuel for our automobiles. Now let's watch again. Let us see Let us see something they call pentane. Pentane has C5, 5 carbon atoms, and 2 times 5. So now we can get what we call isomers. Isomers from pentane. And if we check carefully, alkane exhibits alkane exhibit isomerism. What type of isomerism does alkane exhibit? Structural isomerism. Structural isomerism. Now let's see. How do we mean by structural isomerism? They differ in their structure but have the same molecular formula. So let's go. Pentane has C5H12. This is the molecular formula of pentane. So now let's see the structure that this pentane can generate. Call them isomers. Please pay attention. When we have uh, C, 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 C. This is N pentane. N pentane, straight chain. Okay, 1, 2, 3, 4, 5. N pentane. So this is where the music coming. If you now carry this one, position it, you have C, 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 C. You see? You place it in any of the carbon, because this one is already butane, so it's balanced. Anywhere you place it is the same thing. So this is 2-methyl, because this one is giving us methyl already. So you have 2-methyl butane. Okay? 2-methyl butane. And this 2-methyl butane is called what? Isopentane. 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 And secondly, we have C, C, C. We carry this one again, place it under. So you have CH3, CH3. Have you seen it here now? So these are isomers of pentane. So we have 1, 2, 3. So in this case, we have 2, comma, have you seen it? And the same 2 hyphen di. Have you seen it now? 2, 2 di methyl propane. 2, 2 dimethyl propane. Now, I need to explain something very clearly here. Boiling point and solubility of alkanes. Attention so well, you know. Now, alkanes, as the number of carbon atom increases, the boiling point increases. As the number of carbon atom increases, the boiling point increases. And as such, when the boiling point increases, so boiling point and solubility of alkanes. So when the boiling point increases, it means that, see, the boiling point is increasing, is increasing, is increasing. So, but this boiling point now is very high, is large. The boiling point is large, high boiling point, high boiling point. Now, if we have C, 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 you now branch it. The moment you branch it, okay, you will go back. You see 1, 2, 3, 4, 5, 6. But if you count now, 1, 2, 3, 4, 5. You have already branched it, reducing it, taking this away as a substituent does not. This is now the parent carbon. 1, 2, 3, 4, 5, reducing this long one back to this. So this high boiling point, as you are increasing the number of carbon, it's there. Another way of reducing it is by branching it. So the carbon, the boiling point will start reducing. So as you are reducing the branching, increasing the branching, the boiling point will be reducing. So here, the boiling point here is lower than this boiling point, but they have the same molecular formula, but different boiling points. This one is straight chain, higher boiling point. This one is branched chain. So the lowest boiling point of pentane is 2,2-dimethylpropane. 2,2-dimethylpropane is the lowest boiling point of pentane. The lowest boiling point has the highest branching, and the highest branching is 2,2-dimethylpropane for pentane. I said, let me tell you something about this boiling point because you may be confused. The higher the carbon atoms, the higher the boiling point. But when you start branching, the boiling point starts reducing. So the lowest boiling point is found in the highest branching. Solubility of alkane. Alkanes are water heating. Alkanes are water heating. They do not dissolve in water. So they form float in water. Why? Alkane is less, water is denser than alkane. So alkane floats in water, on water. It cannot dissolve. So it suspends in water. Water is there, is the main. Water is talking about density. Density. It can it's not soluble in water. That is water heating. Then density of alkane is about 0.7 something, 6 something like this. But what 1.0 is for water. So this one is less dense than this. So water has 1.0, density of alkanes has 0.76 approximately. Therefore, alkane cannot dissolve in water. Alkane is less dense and it floats in water. So it's very, very important to note that. And it will help you in your exam. Remember, I said glycerol. Glycerol. Glycerol is propan 1, 2, 3 triol. And this is also called trihydric alcohol. Take note of this. Adamama. Isomerism is the process whereby an organic compound can have the same molecular formula but different structural formula. Different structural formula. Okay, just copy this fast. Now, we have different types of isomerism, but I'm going to give you the most important ones. Okay? Now, we have structural isomerism, we have geometric isomerism, we have um, position isomerism, functional group isomerism, optical isomerism, enantiomer, enantiomerism, okay, and many more. Which type of isomerism is exhibited by compounds with double bond or a ring structure? Which type of isomerism? The answer is geometric isomerism. So that is the answer to the question. What is a functional group? What is a functional group? What is a functional group? You know. All right. Answer. Get ready to know whether you are correct or you're wrong. A functional group is a specific arrangement of atoms in a molecule that determines its chemical properties. That determine its chemical properties. Check if you are correct. If you have the same thing, congratulations. Now, let's watch. Hydrocarbons have alkane, alkane, alkyne. Then classes of organic compounds. We have alcohol, alkanol, alkanoic acid, alkana, alkanones. All right, let's watch again. Please be fast. This alkane has single bond, double bond, triple bond. This is called unsaturated hydrocarbons. This is called saturated hydrocarbons. Unsaturated hydrocarbons, saturated hydrocarbons. Okay, that is that for hydrocarbons. Now, classes of organic compounds, we have alcohol, alkanol. Please pay attention. ROH is the molecular formula. ROH is the molecular formula. Okay? ROH is the molecular formula. ROH is the molecular formula. Then OH is the functional group. Pay attention to this. It's very, very important. ROH is the molecular formula. OH is the functional group. For alkanoic acid, RCOOH, molecular formula. Then COOH, carboxylic acid, which is the functional group. This is hydroxyl group. This is carboxylic acid. This is called functional group. This is called functional group. Okay? So that you not come here and be telling me that they say which one is the functional group. You write RCOOH. You feel it comfortably. Trust Obini what he can do. Now for alkana, we have also ROCHO. This is molecular formula. Functional group is this, CHO minus CHO, okay? Dash CHO is functional group. Share this video so that those that are not here will be aware of it. Share it to on Monday is chemistry quiz. Share this video, okay? Share it. Now, and try to like if you know what I'm doing is good for you, for your own success. Like this video. For alkanone, CO. Okay? Now, there is another thing you need to learn based on the classes of organic compounds. We have alkanol, alkanoic acid, alkana, alkanones. This CO is called the functional group of alkanones. Then alkana, CHO, alkanoic acid, COOH. Then there is what we call ether, amines, and amide. Good. So this ether, we always talk about ROR. Okay? Ether, the functional group is the O. And it is R. This is R, which is alkyl group. Alkyl group attached to O is ether. We can say this is called acosylalkane, or epoxide. Okay, dialkyl ether. This thing here is alkyl, 2-alkyl ether. Okay, so now this is amine. When you have any compound like this, know that it's ether, not ester. Ester is different from ether. Ester is RCOOR. This is ester. This is ether. Ester is RCOOR. Ether is ROR. Now, amines is just NH2. This is the functional group of amines. Amide is a CONH2. This is amide. For amines, we have primary amines, secondary amines, and tertiary amines. But amide is amide, ethanamide, propanamide, butanamide. But amines can be pronounced as aminoalkanes. Aminoalkanes. So take note of it. This is called methoxymethane, or you can call it dimethyl ether. Dimethyl ether or methoxymethane. This is an isomer of ethanol. And ethanol is CH3 C2OH. So this is ethanol. Look at it. Methoxy. This OCH3 is methoxy. So if ethanol, this is methyl group. If ethyl group is here, it becomes ethoxy. Then whatever that is here becomes methane. You see? So I'm going to teach you how to name ether, epoxides, so that when you see any of them, you'll be able to grab them. Now, look at these two. Methoxy methane and ethanol. They are isomer to each other. They exist as what we call functional group isomerism. Functional group isomerism. Because the functional group of ethanol is quite different from that of what? Ether. But they have the same molecular formula, which is C2H6O. This is their general molecular formula. C2H6O, general molecular formula. H is 6, 3 plus 3 is 6, 2, 1, 3, 6. Okay, so this is called functional group isomers. Functional group isomers. Let me give you another example of position isomers. I've given you functional group isomers. When we have CH, something like this, okay? And let's make it okay. Do you know that if this is Cl, chlorine, and every other one is hydrogen, 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 I want to give you another example of isomerism. Position, this position here is 1. And another one again is like this. The same thing. The same thing. But you are no longer seeing it as position 1. But it's now in position 2. All right, now Cl is in position 2 here, but Cl is in position 1. But they have the same molecular formula. They have the same molecular formula, but different position. Okay? This is called what? 1 chlorobutane, but this is called 2-chlorobutane. Now, what is the general formula? How many C do we have here? C4. How many H do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 1, 2, 3, 4, 5, 6, 7, 8, 9H. So H9, and Cl. Okay. So now this C4H9Cl is the same molecular formula for 1-chlorobutane and 2-chlorobutane. Okay. So we have a position isomerism. Please, if you want to say the one that is not clear, be specific. Which particular one is not clear? Is it functional group isomerism or position isomerism or what? You be specific. Okay. Be specific in your question. So functional group in extra is, see it here, COO dash dash. Do you get it now? So this is the functional group in extra, COO. Then functional group in eta is O. So this is the functional group in eta, O. And this is the functional group in ester, COO. Then functional group in amide is CONH2. Then amines, so that you understand it. Not be tomorrow now, they ask you, they look. Say, I don't know what they do. All right. So what's the effect of functional groups on the physical properties of molecules? What's the effect of functional groups on the physical properties of molecules? Let me see your answer there. Let me see your answer. Effect of functional group. All right, Victoria, you tried. It determines each state of matter. That is, the three states of matter is solid, liquid, and gases. Um, okay, you tried, but that is not correct. The answer is it determines the boiling point. The boiling point and the solubility of organic compounds determines the boiling point and solubility of organic compounds. Boiling point and solubility. All right, functional group are important because they determine the physical properties of molecules. They determine the chemical reactivity of the molecules. They determine the physical properties of the molecules. They determine the chemical reactivities, and they are responsible for the biological activity of molecule. Biological activities. They are responsible for the biological activity of molecules. Okay? Hmm. Like this video, share, keep on sharing this video. Like the video and keep on sharing it. Like this video and keep on sharing it. Like this video and keep on sharing it. Okay. Who is credited? Let's know this question. Who is credited? Who is credited with synthesizing urea from inorganic compound? disproving the theory of vitalism. Fast, 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 fast. What type of bond does carbon form? Okay, the first answer is what? Friedrich Wöhler. Who got it? Indicate. If you got it, say blendo. If you are following, just type blendo. If you are following, if you are not following, don't type it. If you got it, say blendo. If you are following what you are doing, say blendo. And the number of people that say blendo determines the continuity of this class. If you are following, just type blendo. Yes, Obonna, you are the first to type blendo. You know, just say hi, hi. Just say hi to me in my chat, you know. So, followed by Victoria. You are following. That is correct. Nke a ka na-ekwu because of catenation and tetravalency. Who told you? Who told you? Yes, desire, joy. Okay. Next question. Why is carbon perpetual? I can see you. Why is carbon unique? Carbon is unique because John So said can form covalent bond. No. Yes, Anastasia, you are welcome. Chinwetalagu. John So, you are welcome. Thank you. I can see you. I can see you. All right, so the question says, why is carbon unique? So what is your answer? Answer is, it is unique because it has the ability long chains and rings. It has the ability, carbon is unique because it has the ability to form long chain and rings. So that is why carbon is unique. That is why carbon is unique. And the last question, what type of bond does carbon form? The answer is covalent bond. Covalent bond. Okay, beautiful question. What is catenation? Catenation. What is catenation? What is catenation? Catenation ability is the ability of carbon to form long chain and rings. Ability of carbon to form long chains and ring. Good. Another question is, why does carbon catenate? The answer is, I'm waiting for you in the comment section. Why does carbon catenate? Why does carbon catenate? Carbon catenates. Carbon can catenate due to its tetrahedral structure. Who got it? I'll catch you. Who got it? It can catenate because of its tetrahedral structure. Right, Ono Anthony, you're correct. Yes, Ono Anthony is correct. Yes, ability of carbon to react with itself and form long chain. Correct. Because of its tetrahedral nature, tetrahedral structure, its structure. Oh, you're correct. Because it can form tetrahedral structure. No, because of its tetrahedral structure, not because it can form. Because of its tetrahedral structure. All right, guess the topic that I'm going to summarize right away. Tell me the topic that is giving you headache. If you get it, type it there. The topic that I'm going to summarize now and now. Tell me the topic that is giving you headache that you think I should summarize now. Keep on liking, like, share the video, share the video, like, share, like. Keep on liking, okay? And tell me the topic I'm about to hit down now. Keep on liking, share the video. Okay. Let's hit it differently so you know what I'm talking about. Electronic theories in organic chemistry and the different electronic effects. Share this video so that your friend will not miss out. Share this video. Keep on sharing this video. Now, there is what we call electronic theories, electronic effects on organic molecules. I believe you already know what an electrophile is and what a nucleophile is. Electrophiles are electron deficient. Nucleophile are electron rich. Electrophiles are electron deficient, while nucleophile are electron rich. So let's pick the first electronic effect. We call it inductive effect. Inductive effect. When we talk about inductive, from the word induction, okay, you transfer of charge, you transmit charge, okay, from one atom to another, but it's based on the difference in their electronegativity. Charge is transmitted, okay, through sigma bond. I believe you already know what a sigma bond is. We shall talk about it now. So, electron donating group, electron withdrawing group, electrophile, nucleophile. Okay. Inductive effect is the transmission of charge along sigma bond due to electronegativity. Differences. Due to electronegativity differences. So we can see we are talking about electronic effects, okay? But this is inductive effect. Inductive effect. Charge is transferred, okay? During covalent bonding, during bonding formation, one atom, the other atom, as in the both atoms contribute electron they share during bonding, okay? Chemical bonding in first semester, you see that electron brings electron. Let's see. So what do we mean by inductive effects? Transmission of charge along sigma bond. What do we mean by sigma bond? This is sigma bond. Okay, sharing of what? Electrons. Equal sharing of electrons. Then if we now have difference in the electronegativity, it will generate this inductive effect. But the question now is, inductive effect is just like polar covalent bonding, where you have charge distribution, charge distribution. Okay, now if you have CH3, CH4, and now this is CH, H, 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 and we want to detach hydrogen from carbon. They have different electronegativity. Do you remember when we say bond cleavage? When we are breaking, bond breakage. So now this can occur through heterolytic breaking of bond because they are of two different atoms, difference in electronegativity. And now, which one is more electronegative between hydrogen and carbon? Okay, so in this case, hydrogen is more electronegative than carbon. So this is going to move. Have you seen it? Have you seen it? Transmission of charge. Transmission of charge. This is cutting out. We are breaking it through heterolytic, and this has more electronegative than this. So when it breaks out, we will have carbocation. Carbocation. Okay? And here we have positive. Have you seen it? Carbocation, it has been broken, and it will have something like this. Carbocation, positive at the carbon. Then you will now have hydrogen minus. Have you seen that this has splitted? But if you watch carefully, this is called inductive effect, whereby this has taken negative charge and this has taken positive charge. This is sigma bond. Charge move to this, charge retained by this. Okay? So the compound, the part that has positive will become what? Look at it. When you have broken this sigma bond, you have separated them. This has positive, we call it CH3. Okay, this has the positive part, and H minus has the negative part. So this is called free radical, like a charge. This one is also charged. And we, in this inductive effect, call it, positive inductive effect. What do we mean by positive inductive effect? Plus 1. This is electron donating group. Electron donating group. E.g., CH3 plus. It donated electron to hydrogen. Okay? Now, negative inductive effect, just like minus 1, is electron withdrawing groups. Okay. Electron donating group can merge with this to form fluoromethane. So the effect is permanent effect. Inductive effect is permanent effect. Inductive effect. Inductive effect is a permanent effect. Inductive effect is a permanent effect. So that if you are asked, you already know. Inductive effect is a permanent effect. Ask me question directly in that particular area you don't understand. Okay, let's talk about negative inductive effect. Now, we mean by negative inductive effect when we say if you are donating, you are taking the electron. Acceptance, okay? They are just withdrawing group that they are taking electron taking. They take electron. You understand? Then the other one gives out electron. That is what it means. Okay? So like chlorine is a negative inductive effect. Why? Because it takes electron to become negatively charged. It's just transference of charges, transmission of charges along. See, have you ever noticed something that we have something like this? Okay. Now, between chlorine and CH3, let's watch what actually happened. The negative will appear. Watch. Now, between carbon and chlorine, which one is more electronegative? Chlorine. Carbon is less electronegative. And this is sigma bond, sigma bond, sigma bond, sigma bond. Okay? And here, the bond will break using heterolytic. I hope you know what is called heterolytic cleavage. Heterolytic cleavage, breaking of bond when they are of different electronegativity. One we take positive charge, the other one we take negative charge. That is exactly the kind of thing that will happen here. So, which one will withdraw the electron? Which one will donate the electron? Okay? The one that will take in the electron is chlorine. Look at it. Everything as if it's accepted by chlorine, forming chlorine negative. Hence, negative inductive effect. So it is if the effect of taking negative electron, negative charge, is the negative inductive effect. Why that of taking positive charge? Okay, because this will leave behind positive, and this will be what? Negative, and we already cleaved it. You have broken it. And chlorine will go its way by chlorine negative, and this alkyl group will go with. That is why this is always willing, ready to react. Okay, is not stable, is unstable. Now, this is positive, is called carbocation, and carbocation is electron deficient. Are you getting it now? So it has given out the electron it has to chlorine. And chlorine has withdrawn its electron from the molecule, taking it. Has taken away the electron it gave before. Then it will become negative, and the one that is now lacking electron becomes positive. Hence, this is called electrophile. Electrophile, because it lacks, it is deficient of electron. Why this will be called nucleophile? Now, because it is electron rich. Mesomeric effect or resonance occurs in compounds, with conjugated systems. Okay, like alternating single and double bond. For example, we have this, 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 and this, this. Okay. We also have this, 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 and this, and this, and this. So finally, this can resonate because it can be expressed like this or like that. And this can also be in this form. Yes, this is the structure of benzene. Okay. And mesomeric effect can take place in benzene, alternating single bond, double bond, single bond, double bond, single bond, double bond. So single bond can be here, anywhere. But in summary, resonance can occur. When resonance occurs, you see the structure there. Okay. All right. So this is what I mean by conjugated system. A system where you have alternating single bond and double bond. See here, single bond and double bond. All right. So now, so here, the plus M effect, positive mesomeric effect, because we also have positive and negative mesomeric effect. Electron donating group. Okay. Electron donating group. Releases electron into the conjugated system. For example, remember, in this conjugated system, the electron that will be donating, the group that will be releasing electron must be electron rich. Okay, must be rich in electron, and we can call them nucleophiles. And the nucleophile we have, OH is there, NH2 also is there. Nucleophiles. Okay? Yes, even though OH is positive and negative, it is electron rich. So it will release electron. It will release electron to the conjugated system. So it must be electron rich for it to release electron to the conjugated system. In the process of doing that, the conjugated system becomes negative, and this seems to be partially positive. Okay, and when it is partial, it's not permanent, just like the other one, the other electronic effect. In this case, you'll be using delta positive and delta negative. Okay, so the negative mesomeric effect, please pay attention, is very important. The electron withdrawing group, in this case, the negative mesomeric effect, we are not talking about electron withdrawing, electron that is supposed to take in, okay, that is supposed to take in, absorb, because they are they grab the electron to themselves, they withdraw electron to themselves. Good. So these are electron withdrawing groups. Okay, they pull electrons away from the conjugated system. They pull electron away from the conjugated system to themselves. Okay? So the key point here now is that here, the electron donating group releases electron to the conjugated system. Example, OH, NH2. Then negative effect, the negative mesomeric effect, electron withdrawing group pull electrons from the conjugate system to themselves. So example is CN, cyanide, and NaO2. Take note of it. Cyanide and NaO2. So here, mesomeric effect is not a permanent effect. Is not a permanent effect. Mesomeric effect is not a permanent effect. Why inductive effect is a permanent effect? Okay, inductive effect is a permanent effect. Mesomeric effect is not a permanent effect. Okay, so it is very important to know that. Again, keep on sharing, like, keep on sharing, like. I hope you are following. If you are following, say Blendo, I'm following. If you are following, say Blendo, I'm following. All right, so keep on sharing, like, and like. All right, so okay, let's look at this question. The inductive effect in organic compound is due to dash. What's your answer? Select A, pi electron shift, B, sigma bond polarization, C, resonance, D, temporary electron transfer. Please drop your answers in the comment section. I'll give you 1 minute to do that. The inductive effect in organic compounds is due to dash A, pi electron shift, C, electron transfer. When you answer it, it shows that you're actually following. What is the correct answer there? D is wrong. Resonance effect is wrong. Keep trying. At least we have eliminated D and C. Keep trying. Oh, who is Johnson? Because we have eliminated C and D, you now pick A so that we can eliminate A or add A to. My man, you are wrong. It cannot work for you. We have 2 options left, so don't pick anyhow. Don't pick anyhow. But if you remember when I talked about the inductive effect, I said is the transmission of charge along the sigma bond. I said it. Why are you now confused? Sigma bond, is it not B? Is that symbol not B? Sigma bond. Hey, the answer is B. I said it here. Go back to your notes. The answer is B, sigma bond. Transmission of charge through the sigma bond. I said it. Wow. Which group shows a positive inductive effect? A, B, C. D. Positive inductive effect. What's your answer? The answer is C. Correct. Victoria, go and revise what you have learned. The answer is CH3. C. That is accurate. The answer is C. Okay. Which group shows a negative inductive effect? Correct. NO2. Perpetua Onyekachi. You are right. You got it right. The correct answer is NO2. Correct. So check it very well, though. I have explained it before. The inductive effect is dash. A. Temporary. B. Reversible. C. Permanent. D. Only in conjugated system. Correct answer should be dropped sharp sharp. Oh, Perpetua. In this one, you are wrong. Perpetua, you're wrong. It's not A. Joy, you are wrong. Joy, you are not wrong. Oh. Joy, you are correct. Joy said permanent. Yes, Joy Uneke, you are very correct. The answer is permanent. Keep on liking the video. Keep on liking the video. Share the video. Okay. Yes, permanent is correct. All right, keep on liking, like, and like. Share the video and like the video. Okay. When we talk about conjugated system, we are actually talking about single bond and double bond. And when we have single bond and double bond, it means it is alternating. This is double bond, single bond. And now here is only sigma, sigma. But here is pi and sigma bond. So pi and sigma bond. So for mesomeric effect, we are actually talking about effect that takes place in pi and sigma bond. So that you understand it too, it occurs in a conjugated system. Conjugated system means alternating pi and sigma bond, single and double bond. So here, there is presence of pi bond and there is presence of sigma bond. Why for inductive only sigma bond, single bond, there is nothing like pi bond. Take note of it. Okay, so look at this question. Mesomeric effect occurs in compounds having A, only sigma bond, B, conjugated pi and sigma bond, C, only pi bond, D, free radicals. The answer is conjugated pi and sigma bond. So which of the following groups shows plus M effect, positive mesomeric effect? Huh? So here the answer is OH. Then here the answer is NO2. Okay. Here it donates or releases electron to the conjugated system. So OH releases electron to the conjugated system, while NO2 takes electrons away, withdraw. Okay. Electron donating group, withdrawing donating, electron withdrawing group. So this is electron withdrawing group, electron donating group. So you go back to your, the mesomeric, is it permanent or temporary? Mesomeric is permanent. Okay. Mesomeric effect is also permanent, like inductive effect. Mesomeric effect is permanent, just like inductive effect. So we have what we call electromeric. Electromeric effect. Electromeric effect is temporary and reversible. Electromeric effect is temporary and reversible. So in electromeric effect, we have positive electromeric effect and negative electromagnetic effect. In positive electromagnetic effect, electrons are transferred towards the electrophiles. You already know what electrophiles are. Electrons are transferred towards the electrophile. That is positive electromagnetic effect. Why negative electromagnetic effect? Okay. Effects. Electrons are transferred towards the nucleophile. Electrophiles are Okay. I hope you can hear me. Okay, sorry. My mic turned off. I didn't notice. Okay, sorry. So I was talking about electromeric effect. So sorry for that. Electromeric effect. I believe you now know what electromeric effect is. Okay. Electromeric effect is observed in unsaturated compounds like alkenes. Okay. Now, for positive electromeric effect, when an electrophile, that is a hydrogen plus, okay, and hydrogen plus is an electrophile. Hydrogen plus doesn't have any electron, so it is electron deficient. When electrophile is added, okay, when electrophile is added to an alkene, is added to an alkene, okay, electrons move towards electrons move towards the electrophile. And when it moves towards the electrophile, something actually happens. We say it is positive electromeric effect. Positive electromeric effect. Then, and I said again, when hydrogen cyanide, so that we will be able to get cyanide, which is a nucleophile, electron rich. When it is added, when hydrogen cyanide is added to alkene, okay, when HCN is added to alkene, all right, negative electron also moves. Electron moves towards the nucleophile. So as it moves towards the nucleophile, we say that it is negative electromeric effect. Negative electromeric effect. So this is how you need to understand them individually. Okay? If they want to ask a question, they will say the electromeric effect is observed in dash. Answer, unsaturated compound. Unsaturated what? Compound. I say again, electromeric effect is observed in what? The answer is what? Unsaturated compound. Okay, the second question, the electromeric effect is dash. The answer is temporary and reversible. It is temporary and it is what? Reversible. In the positive electromeric effect, electrons are transferred towards dash. Answer, electrons are transferred towards electrophile. In the negative electromeric effect, electrons are transferred towards the nucleophile. Electrons are transferred towards the nucleophile. Now, addition of hydrogen plus ion to an alkene involves which effect? How will you know? You look at hydrogen plus. Hydrogen plus lacks electrons, so it is an electrophile. Automatically, that system is plus electron plus E plus or positive electromeric effect. So that effect is positive electromeric effect. Okay. Now, when you have addition of HCN to an alkene, automatically HCN will produce cyanide, and cyanide is nucleophile, electron rich. Okay. And when we have nucleophile, which is an electron rich, the effect is negative electromeric effect. Negative electromeric effect. Now, what is a hyperconjugation? Hyperconjugation is also called no bond. Hyperconjugation is also called no bond resonance. So this is called hyperconjugation. Hyperconjugation, no bond resonance. So now, hyperconjugation involves delocalization of hyperconjugation involves delocalization of sigma electrons of single bond, carbon-hydrogen bond, carbon-hydrogen bond, okay? Carbon-hydrogen bond involves delocalization of sigma electrons of carbon-hydrogen bond. Okay, there is what we call carbocations. I know you've heard of carbocation. Carbocation C+. Which effect stabilizes carbocations strongly? The answer is what? Hyperconjugation. 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 Okay, now let's see how we can answer this question. Which effect is responsible for resonance stabilization in benzene? If you get this one, you are good to go. Which effect is responsible for resonance stabilization in benzene? A, inductive effect. B, mesomeric effect. C, electromeric effect. D, hyperconjugation. If you get it, oh God, means you are good. If you get it, you are good. Okay. So if you are following up to this time, I would like you to say, I will type it. Type it. I'd like you to type this, and it's going to help you. I am not a failure. I will make it. I know who I am. I am not a failure. I will make it. Type it. I am not a failure. I will make it. I know who I am. God's grace is abundance in me. I am not a failure. I know who I am. I'd like to type it if you are still with me, if you are following me, if you are still understanding what I'm saying and knowing what I'm doing. You say, I am not a failure. I know where I am. God's grace is abundant in me. I am not a failure. I know who I am. I will make it. God's grace is abundant in me. God's grace is abundant in me. I am not a failure. I will make it. I know who I am. God's grace is abundant in me. Type it, like, and share this video. I am so glad you stayed up to this hour with me. And I believe success shall hit your way. You shall see success. Mesomeric, that is beautiful. Correct. Mesomeric effect. So the answer is mesomeric effect, B. Okay? Mesomeric effect, B. Type what I asked you to type now. Okay? Type what I asked you to type now. Type what I asked you to type now. I am not a failure. I'll make it. I know who I am. God's grace is abundant in me. God's grace is abundant in me. I am not a failure. I will make it. I know who I am. God's grace is abundant in me. Okay? Type it, say it again and again and again. Like, share this video. Thank you for standing with us, staying up to this hour. Thank you. Thank you so much. I so much appreciate each and every one of you for your time, for your patience, and for your understanding. I believe you learned a whole lot, okay, for your data that you are able to utilize. And for the whole thing, I thank you. I thank you. I believe is success. Success is what we shall get from all of this. Last semester we made it, and this semester is going to be double. Whatsoever you had in last semester, this semester shall be improved. Okay? Thank you so much, and enjoy your day. See you same time, same channel on Monday morning. I'll be with you. Bye for now.